Now, welcome back again to problem set 3.1, solution to 3.1 from Engineering Mechanics by Tata McGraw-Hill, written by famous American professors, Professor Timoshenko, Professor D.H. Young from Stanford University, and Director J.B. Rao and Professor Sukumar Pati from India. This book has been a classic book for almost more than 80 years. So, now the problem is on parallel forces and couples, right? Now, before I explain this, I have to explain the properties of like parallel forces and how to find out the resultant. And given a resultant, how to split that into two like parallel forces. So before I proceed, let me explain the theory part of it. Now if you look at the diagram, here is from the point A, force P is acting to this side, and from the point B, another force Q is acting to this side. Both P and Q are parallel, means angle between them is 0. And this derivation, r square is p square plus q square plus 2pq cos theta, you must have done in your school days, where is the r is the resultant of a p and q, and theta is the angle between p and q. Now, since p and q are like parallel, means angle between them is 0. If I put theta is 0 here, cos 0 is 1. So this expression reduces to r square plus is equal to p square plus q square plus 2pq. So that is what I have written. Since p and q are like parallel, angle between p and q is 0, so cos 0 is 1. So your r square reduces to this. And the right hand side is nothing but whole square of p plus q. So taking square root on either side, we are left with r is equal to p plus q. Means if there are two forces acting in the same direction, P and Q, then their combined effect, means the resultant is just the arithmetic sum of those two forces P and Q. So R is just equal to the arithmetic sum. Now what do I do to explain Brignon's principle? So what I have done is I have drawn a perpendicular to the line of action of P and the line of action of Q. This dotted line is the perpendicular. Let it be M here, let it be N here. So this angle is 90 here and this angle is 90 here. So let this angle is equal to alpha. Therefore this angle will be alpha since it is vertically opposite. Now if you take cosine of the angle in the triangle CMA, this being 90 and here this being 90, if you take cosine of this alpha, it will be base over hypotenuse, that is MC over AC. Similarly, if you take cosine of the angle alpha here, it will be base over hypotenuse, that is BC over CN. And if you cross multiply, then you get CM in this triangle. In the triangle AMC, CM will be AC times cos alpha. If you take cos alpha here in this triangle BNC, right angled at N, it will be base over hypotenuse CN over CB, and if you cross multiply, you get CN is equal to BC times cos alpha. Now that the principle of Brignon's theorem, what it is, the moment of the resultant R, this is the resultant R of a P and Q. The moment means the turning effect of this resultant about C. Since this resultant is passing through the point C, the resultant does not have a perpendicular distance from C, so its moment about C will be 0. And the principle says the moment of R about C should be equal to the algebraic sum of moments of a P and Q about the same point. Means this resultant, whatever moment, means the turning effect, this R produces about C, that will be equal to the moment of the force P about point C plus the moment of the force Q about also the same point C. Now P and Q both will have different turning effects about point C. Q will have a turning effect like this, anti-clockwise, and P will have a turning effect clockwise. So both must be equal and opposite. So applying the principle, R times its perpendicular distance, this is the line of action of R. Had this R been here, then it would have a perpendicular distance. Had this R been here, then it would have a perpendicular distance from C. Since it is passing through C, the resultant R does not have a perpendicular distance, so its turning effect about point C is 0. So I have written R times the perpendicular distance, that is 0, will be Q times Cn minus P times Cm. Q times Cn is the perpendicular distance from the line of action of Q. This will produce an anti-clockwise turning effect, which I have taken as positive. And the line of action of P from the point C has a perpendicular distance MC. So the turning effect, the moment of the force P about C will be P times MC. P times Cm. Why I have taken it negative? Because it is clockwise. And this is positive because it is anti-clockwise. Now put the value of Cn and Cm. So this becomes 0. Q times BC cos alpha is minus P times Cm is equal to AC times cos alpha. Make the side change, bring this term to the left hand side, becomes positive. This remains on the right hand side. Now cos alpha cancels. So P times AC is equal to Q times BC. And also, you can well see from the diagram, your length AB is equal to AC plus BC. Your AB is equal to AC plus BC. So what is the conclusion? That is important, so that we can solve this problem and understand its solution easily. So what is the conclusion here? What is the conclusion here? The conclusion I have written here, the resultant of like parallel forces divide AB internally, not externally. Like parallel forces, the resultant of P and Q, which is acting from here, that point has to be within AB, not to the right of B or not to the left of A. It has to be internally. It has to be a point internal between A and B. And it must act parallel to both P and Q. So that is the conclusion. Once that is understood, now let us go back to the solution. The solution part, problem set 3.1, solution to 3.1, part A. So if you look at the diagram, this is the original diagram given in the book. I have redrawn it, enlarged it. This point is small a, this point of small a, this point is B, this point is small b. At this point, a resultant is acting, which is given as 4000 Newton. Resolve this 4000 Newton, as shown in this figure, into parallel components P and Q acting respectively, one along AA, that is P, and one along BP. So P is on this side, Q is on this side. So the resultant, since this is the resultant, and we have been asked to find P and Q, P is to this side and Q is to this side, means the resultant is internally acting between P and Q. So this 4000 will be just numerically equal to P plus Q, the arithmetic sum. And if you look here, from here to here, from here to here, 1 unit, 1 unit, 2 units, from here to here, here to here, here to here, when put together is 1 unit, 1 unit, 3 units. And the line of action of P to this side and the line of action of Q to this side, the line of action of P from the point A has a perpendicular distance 2 units. the line of action of Q from A has a perpendicular distance of 3 units. So, since given R is equal to 4000 Newton and we know R square is this much, which I just explained, and if theta is 0, R is equal to P plus Q. And I just explained the conclusion. The resultant of like parallel forces divides the line internally. So therefore, since R lies between P and Q, so it is a system of like parallel forces. Means the resultant is just the arithmetic sum of P and Q. So this R will be equal to P plus Q. I have redrawn a diagram. So this R, which is 4000, will be equal to just P plus Q. And this is 2 units, this is 3 units, which I explained here. 2 units, 3 units of length. So P times 2, that is the moment of P about A, is equal to Q times 3, that is the moment of Q also about A, and they must be equal. This is what I explained you here. Both must be equal. So equal and opposite means the moment of the force 4000 Newton about A is 0, and that must be the algebraic sum of the moment of the force P about A and moment of the force Q about A. So P times 2 will be equal to Q times 3. So if you take 2 to the left hand side, P becomes 3Q over 2. Now then come back here. Your 4000 Newton is equal to the arithmetic sum of P and Q. So for P, I write 3Q over 2, and Q I keep it as is equal to 4000.